How could Youyou receive the Nobel Prize and the Lasker Foundation Award in Medicine? Lecture 8. Artemether was the most important antimalarial invention after artemisinin. However, Youyou's Dihydroartemisinin was the biggest fraud scandal in the world medicine history. 2015 Nobel Prize in Medicine winner Youyou was an academic cheater and a liar who had made the biggest academic scandal in the history of world science. Soon after the structure of artemisinin was discovered, Youyou from Shanghai Institute of Materia Medica invented Artemether derived from artemisinin in 1976, which was the most important antimalarial drug invention after artemisinin. In 1986, Youyou falsely claimed that Dihydroartemisinin had 10 times antimalarial efficacy than artemisinin. However, the true efficacy ratio was less than double. Through such extremely implied efficacy propaganda, Youyou made huge money by selling Dihydroartemisinin in the third world market. Although the drug artemisinin could quickly inhibit the chloroquine-resistant plasmodium in the blood and normalize the patient's body temperature. However, it has two serious shortcomings. Number one, the cure rate is lower than 30%. This means that more than 70% of malaria patients cannot be fully recovered, and the plasmodium come back in 28 days. One major cause was that artemisinin is not strong enough, which could not cure plasmodium completely in 7-day antimalarial treatment course. Number two, artemisinin is not soluble in water or oil. The water mixed with the floating artemisinin powder intramuscular injection had caused many patients' buttock muscle clumped for many long time and even necrosis. Therefore, the 523 Project Office realized that the drug artemisinin is not the terminator that could completely eradicate the chloroquine-resistant malaria disease from China. In February 1976, the 523 Project Office assigned a new task to Shanghai Institute of Materia Medica to modify the structure of artemisinin in the hope to develop a stronger and injectable antimalarial drug. Then the Chemical Synthesis Office of the Institute took in charge this task. Because the Chinese name of artemisinin was still called Huanghaoshu in 1976, then Yunnan Institute of Materia Medica provided more than 10 grams of Huanghaoshu crystal as the source material for the modification. The 523 Project team of Chemical Synthetic Office had 7 members, headed by Li Liangchuan and Li Ying. However, in February, whole team was busy working on another new drug at the Shanghai 16th pharmaceutical factory, so the modification on artemisinin could not start immediately. In August 1976, the team returned to Institute from factory in order to clearly determine which part of the structure is critical for keeping the antimalarial properties of artemisinin. The 523 team conducted several chemical reactions on artemisinin. There were only 3 possible outputs of the reactions. Case 1. Artemisinin was completely destroyed if applying alkaline reactions. Case 2. Lost 1 oxygen molecule to get deoxyartemisinin if applying hydrogenation reactions. Case 3. Obtained 2 extra hydrogen molecules to get the reduced artemisinin if applying reduced reactions. If ignoring the case 1, we will have 50% chance to get either deoxyartemisinin or reduced artemisinin. Therefore, both of them were not invented by anybody. Deoxyartemisinin lost the antimalarial property. The molecular formula is C15H22O4. From the right structure picture, we can see that the peroxy group was not existed anymore. This is the main reason why deoxyartemisinin lost the antimalariality. Reduced artemisinin kept the antimalarial property. The molecular formula is C15H24O5. From the right structure picture, we can see that 1 hydrogen goes to carbon C12, and the other one goes to the oxygen molecule to make a hydroxyl group OH at carbon C12. But either configuration was possible. Therefore, the reduced artemisinin has 2 apimer structures, alpha and beta. Through the experiments and analyzing, the 523 team of Shanghai Institute of Materia Medica realized the only way to do the modification on artemisinin was to obtain the reduced artemisinin first by the reduced reactions. Moreover, the only one handle for the modification was the hydroxyl group OH connected to carbon C12. That was the basic modification theory. The following was a report about the antimalarial efficacy ratio over artemisinin obtained by Gu Haoming of Shanghai Institute of Materia Medica in 1976. Here, SD90 is the required dosage to suppress 90% of plasmodiums. Therefore, the antimalarial efficacy ratio between reduced artemisinin and artemisinin is about 6.20 divided by 3.65 equals 1.70, approximately equals 2. Here, we have to emphasize that the 523 project office required to use the chloroquine-resistant malaria strain to measure antimalarial efficacy. Please see the following paper, The Chemistry and Synthesis of Qinghao Derivatives, published in Journal of Chinese Traditional Medicine in 1982. It was clearly written, each compound dissolved in tea seed oil was injected intramuscularly into mouse infected with the chloroquine-resistant strain Plasmodium, and also written SD90 was determined for each compound. In the first page of this paper, we also can read artemisinin lateral was nearly twice as active as artemisinin. That means the antimalarial efficacy of reduced artemisinin is nearly double of artemisinin. However, we will see how Youyou played cheating tricks and fabricated this antimalarial efficacy ratio later. In addition to use SD90, there are many 523 teams used ED50 or SD50 to measure the antimalarial efficacy. Here, ED50 is the required dosage to cure 50% plasmodium, and SD50 is the required dose to suppress 50% of plasmodium. However, when using them to calculate the efficacy ratio between two drugs, the result should be approximately the same. Since 90% of falciparum malaria cases in the world are resistant to chloroquine, therefore 523 Project Office strictly required the chloroquine-resistant malaria strain must be used for measuring the efficacy of drugs. Why reduced artemisinin was not suitable as an antimalarial drug? Number 1. The antimalarial efficacy of reduced artemisinin against the chloroquine-resistant malaria strain is only about double of artemisinin, which is not strong enough. In page 74 of her book, Qinghao Antimalarial Research, published in 1979, Youyou claimed that the antimalarial efficacy of reduced artemisinin is increased to 6 times of artemisinin. However, this result was not officially confirmed by 523 Project Office because of not using the chloroquine-resistant strain. Number 2. Reduced artemisinin is not soluble in water or oil. Therefore, it was impossible to develop to an intramuscular injectable medicine. Number 3. The molecular structure of reduced artemisinin contains an hemiacetal, which was not stable by molecular electrophilical theory. Because of such shortcomings, the 523 Project team of Shanghai Institute of Materia Medica did not consider to develop the reduced artemisinin to a new antimalarial drug at that time. In October 1976, Li Ying and her colleagues used solvents ether, carbonate, and carboxynate to treat the reduced artemisinin and synthesized more than 100 derivatives. After the pharmacological testings with chloroquine-resistant rodent malaria strain, it was found that the derivative SM224 was the best. This was because, number 1, the value SD90 against the chloroquine-resistant strain is 1.2 for SM224 beta and 1.16 for SM224 alpha. Therefore, by a simple calculation, the antimalarial efficacy of SM224 is about 6 times of artemisinin. Number 2, SM224 is soluble in oil. Therefore, the derivative SM224 was promising to develop to a strong intramuscular injectable antimalarial drug. In November 1976, the derivative SM224 was named to be a new antimalarial drug Artemether by Shanghai Institute of Materia Medica. Soon after, Zhu Dayuan of Phytochemistry Office found that he already obtained Artemether directly from Artemisinin in an experiment earlier. Essentially, Youyou's method was the combination of Li Ying's two experiments without the middle process of isolating the reduced Artemisinin crystal. However, Li Ying's method has a very clear logic of the scientific developing process. Therefore, the main credit for the invention of Artemether was confirmed to belong Li Ying and her colleagues by the 523 Project Office. But Zhu Dayuan's method was adopted by Kunming Pharmaceutical Factory to produce the Artemether directly from Artemisinin. In June 1977, the 523 Project Office held a special conference antimalarial chemical compound in Shanghai. Li Ying and her colleagues presented several papers in the conference to talk about the structural modification theory of Artemisinin and the producing process of Artemether, including Zhu's one-step direct production method. After the conference, in August 1977, following Li Ying's modification theory and the production method, Liu Xue, the engineer of Guilin Pharmaceutical Factory, synthesized succinate half-ester coded A04 from reduced Artemisinin. Its sodium salt, coded A04Na, is water-soluble. In 1979, the derivative A04Na was developed to the world's first intravenous injectable antimalarial drug, artesunate. From 1978 to 1980, the 523 project teams conducted clinical trials by using Artemether tablets and oil-based intramuscular injection to treat malaria cases in Hainan. Totally, 1,088 malaria cases were cured, including 828 falciparum malaria cases, of which 56 were cerebral and 99 were completely failed by using chloroquine. In January 1981, 523 Project Office held the Artemether Appraisal Conference in Shanghai. All judges agreed that Artemether was much stronger than Artemisinin, especially its intramuscular injection created an advanced anti-malaria treatment history, which westernized Artemisinin. Moreover, its cure rate was increased to 80%. This was a significant improvement comparing to the 30% of Artemisinin. Therefore, Artemether will be the terminator to eradicate chloroquine-resistant malaria disease, at least in China. Artemether caught the attention of WHO. On December 8, 1980, Dr. Halfdan, Secretary-in-General of WHO, sent a letter to China Ministry of Health, Qian Xinzong, and wrote the following. The World Health Organization Malaria Chemotherapy Working Group wishes to hold a research, discussing, and evaluation conference on the anti-malaria drug Artemisinin and its derivatives in China in the near future. Later, China and WHO agreed to set up the conference time in October 1981 at Beijing, which was the first time such a conference held outside Geneva. The conference object was treating malaria by artemisinin and its derivatives, but all presentations and speakers were decided by China. Totally, there were 7 papers presented on the conference, all by Chinese speakers. Presentation 1 talked about to produce artemisinin by the gasoline extraction method, and Presentation 2 talked about the successful clinical trials by using artemisinin from 1975 to 1978. Therefore, those 2 presentations proved that Youyou did not obtain artemisinin and did not have successful clinical trials, because the gasoline method is used to produce Huanghao, and the clinical trials from 1975 to 1978 were also using Huanghao. Youyou did address the Presentation 3 about the structure of artemisinin. However, she was the only speaker could not speak English. Relying on the simultaneous interpreting, her speech became very boring, and there was no response from the audience. The Presentation 4 about artemisinin structure modification and Artemether received huge enthusiastic responses from the audience. It was obvious that the WHO scientists was only interested to learn how to produce the strong anti-malaria drugs. After the conference, following Li Ying's method, WHO scientists did synthesize another derivative anti-malaria drug, Artemether, in 1985. Actually, it was Li Ying's abandoned derivative sample SM227 because its efficacy was only 3 times of artemisinin. Please see the following table about SM227. This meeting also proved that Youyou's 1986 new drug artemisinin certificate was illegal because artemisinin already existed in 1981 on this WHO meeting. After her crystal Qinghao 2 failed in 1973 clinical trial in Hainan, Youyou did not have any progress to find new anti-malaria drugs. In 1986, Youyou tried to make the reduced artemisinin to be a new anti-malaria drug. However, its lower anti-malaria efficacy was the biggest obstacle. Then Youyou and her colleagues collaborated to make the biggest medicine cheating scandal in the Chinese medical history by the following tricks. Trick 1. Rename reduced artemisinin to dihydroartemisinin, so that people could believe this is a new compound. Trick 2. Using improper data to claim that its anti-malaria efficacy became 10 times that of artemisinin. Trick 3. Obtain the official new drug certificate for dihydroartemisinin from China Ministry of Health, such that to crack down all existing objections from other scientists. Now let's listen how Youyou said in her Nobel Prize speech.
1973年起，为研究青蒿素结构中功能奇特而制备的衍生物，经苯氰化钠还原，发明了杀青青蒿素。1992年 再获得杀青青蒿素的新药证书。杀青青蒿素的药效高于青蒿素10倍。
In the above speech, Youyou made two big lies. Lie 1. In 1973, Youyou and her colleagues invented dihydroartemisinin. Reality check. In 1973, Youyou even was unable to obtain the pure artemisinin. How possible to invent its derivative dihydroartemisinin? Lie 2. The antimalarial efficacy of dihydroartemisinin is 10 times that of artemisinin. Reality check. This is true only for chloroquine-sensitive malaria strain, but false for chloroquine-resistant malaria strain. What a true misleading statement! Under the unreal tenfold antimalarial efficacy propaganda, the dihydroartemisinin was sold in the world market for the extremely high price. Many countries in third world had spent huge money to buy dihydroartemisinin, but only get much lower antimalarial power than they expected, and treated much less patients because of limited funding. Therefore, Youyou and her institute must be responsible for the deaths of thousands of patients in Africa because the expensive and lower efficacy dihydroartemisinin failed to provide enough treatment against the chloroquine-resistant malaria disease. We will continue this false tenfold antimalarial efficacy issue of dihydroartemisinin in more details next time. Bye-bye.